Hello there. This video is going to introduce the concept of Z-scores, which we'll define in a moment here. But to motivate why we're going to need to use them, we're going to start with an example. So two students, Paul and Ringo, are taking different sections of the same course. Paul has an average of 82%, and his class average is 75% with a standard deviation of 4.5. Ringo has an average of 80%, and his class's average is 74% with a standard deviation of 3%. Who would you say is the better student? So before we go on to talk about this, I'd invite you to pause the video and, maybe keeping in mind what we've learned the past few days, decide who you think would be the better student based on the information that we have there. Okay, so you're back, and now I'm going to go through my interpretation of this. Typical answers I hear for this, right? A lot of people would argue Paul simply because he has the higher number. Okay, some people would argue Ringo because even though he has a lower average, his class average is also lower, and the standard deviation is smaller, so maybe that affects it somewhat. Okay, so to put it in perspective, we're going to draw a couple of bell curves here, and we're going to fill in the details for each student. Okay, so let's mark off okay, so there's the middle, right? So if this was Paul's class, right, his class average, 75, would be sitting right there. Okay, and recall, if we go one standard deviation away, okay, right, this is one standard deviation going this way, that's going to add 4.5%. So at one deviation, we'd be at 79.5%. Okay, if I go another deviation away, okay, that's adding another 4.5%, and I would be at 84. Okay, so Paul himself is going to be sitting, well, there's 84, so right about here. Okay, so somewhere in between there. And now we'll do the same analysis for Ringo. Okay, so his class average was 80. Sorry, no, that was his average. His class average is 74. Okay. If I move one deviation forward on his curve, then I would be adding the deviation 3%. So now we're at 77. And if I add that deviation again, okay, we're going to be at 80. So where does Ringo sit? Well, his mark was 80, so he is sitting right here on that deviation. So if I think about this in terms of the relative distributions of each class, right, however many students are in here, Ringo is ahead of more students, right, a higher percentage of the class than Paul is. It's not a big difference, but he is a little bit further ahead because he is 2 full deviations away from the mean, and Paul is less than 2 deviations away from the mean. So again, if we're thinking in terms of relative setup, I would argue that Ringo is going to be the better student. Now, it might be nice to know, right, if Ringo wasn't right here, let's say if he was a little bit back as well, it might be helpful to know exactly where this is, right? How many deviations ahead of the mean is Paul? Okay, Ringo's was easy because it's on the line, right? How far forward is this? Okay, so that's really what Z-scores are all about. So here's the definition. Given a set of data with a mean of X bar and a standard deviation of sigma, the Z-score of an individual datum, so an individual number, is X minus the mean divided by the standard deviation, and that gives us our Z-score. Again, what this is telling us, right, is how many how many standard deviations this score is away. So what we're really doing here is finding the distance from the data point to the mean, and then dividing by the size of the deviation to give us the number of deviations that it's away from the mean. So let's put this to use and see how it works. So we know what Ringo's is supposed to end up at, so we'll start with Ringo. Okay, so for his Z score, okay, his data point, so he had a percentage of 80. The average from his class was 74, and the standard deviation was 3. Go. So 80 minus 74, we have 6 over 3, and that equals 2, which is what we saw in the graph, right? Ringo's exactly 2 standard deviations ahead. Okay, for Paul, okay, I won't write down the formula again, but I'll fill it in. So he had a score of 82, the class average is 75, and the standard deviation was 4.5. Okay, so that's going to give us, let's see, 7 over 4.5. Okay, and rounding that off to 2 decimal places, that's a Z score of 1.56. Okay, and we'll talk about the rounding part in a second here. Okay, so yeah, and again, on the diagram, that seems about right? 1.5 deviations would be just before this, so it's 1.56 deviations away. Okay, so again, that kind of shows that Ringo is farther away from the mean in his class than Paul is. Now, that's nice, but you might remember yesterday we were talking a lot about percentages, right? 1 standard deviation in both directions gives about 68% of your data, right? 2 deviations gives 95%. 3 deviations gives 99.7. So it would be helpful if we could get percentages to go with this, right? What percent of the data does that put you at, okay? So what might be more helpful is to figure out the percentile rank, right? Instead of knowing the number of deviations away, I'll say, what percent of the class is this student better than? Where are they sitting on that graph? Okay, so in order to do that, we need to have an idea of how that works, right? How does the Z score connect to the deviation? So for this definition, okay, it's not super important, but it's more of a history lesson here. The standard normal distribution, okay, which is N01, has a mean of 0 and a standard deviation of 1. Okay, so what that means is, right, no matter, all the data points in this distribution are the same as their Z score, right? If you imagine you would take your mean, right, so your Z score, so let's say, you know, if I was talking about 1.5, right, I'd take away 0, so 1.5, I divide it by 1, and still 1.5. Okay. So this is the distribution that a long time ago, some mathematicians and statisticians took this and really, really carefully figured out, as I move up that scale, what percent of the data am I ahead at, okay? So that we don't have to. So this leads to what's called the Z score table. So if you go to the back of your textbook, okay, I think this is Appendix C, but it's on page 398 and 399. Okay, you're going to see a Z score table that looks a lot like the one I'm going to put up now. Okay, right here. Okay, so what this gives us is you take your standard deviation and it converts it to the percentile rank. So that's going to be our next example, and I'll show you how to use this. Okay, so again, for Paul, okay, the Z score was 1.56. Okay, so the reason we rounded it there is because the table goes to 2 decimal places. So I'm going to go to my table, and I'm going to look up 1.56. So the way I do that, I start with the first 2, right, 1.5. So I go down here, here's positive 1.5, and then the hundredths place is up along here. So here's the 0.6, okay? So I go 1.5, right, 1.5, 0.51, 5.2, 5.3, 5.4, 5.6 is right here. So I get 0.9406. Okay, which is approximately 94%. Okay, so what the table has told us is that in Paul's class, he is doing better than 94% of the class. He is near the top of that class. Okay, for Ringo, same idea. Okay, he got a Z-score of 2. So I'm going to go to my table. And that would be 2.00. So that's right here, 0.9772. Okay, which is about, it's closer to 98%. Okay, so in Ringo's class, he is, depending on how many people are there, he's pretty much the top student, right? If he hasn't, he's better than 98% of the students in his class. Okay, so again, the Z-score, when you go to this table, okay, it's really pumping out how much of the data lies below your target score. Okay, and again, if you look at your textbook, right, this side of the table is negative. Okay, also note that in your textbook, I think it only goes to 2.9. You can see that the numbers get really, really tiny after that. Okay, because realistically, beyond 3 standard deviations, there isn't much left. Okay, but that's how you use it, right? And obviously, the negative Z-scores, right, those are for values that are less than your mean, and the positive ones are for values that are more than your mean. Okay, so that's how you use that table. So finally, a follow-up example. Paul's teacher, Mr. G. Harrison, gives out awards to the top 20% of the students at the end of the semester. What mark would you need in Mr. Harrison's class to get an award? So where would you find the cutoff for the top 20 students? Okay, so again, if this is my rough Z-score table, top 20% is going to be somewhere up here. Okay, and I'm interested in, right, where is that exactly that I hit that top 20%? Now this was Paul's class, so again the mean was 75 and the standard deviation was 4.5. So how this all connects, well, I can use my Z-score table kind of in reverse here. I would like to know the Z-score. What is the position of this point? Okay, but remember, okay, the table doesn't tell us what's above, it tells us what's below. Okay, so equivalently, I'm really asking at what point am I better than 80% of the data? Okay, what Z-score is at least 80%? So I'm going to go into the Z-score table and try to find 80%, which would be 0.8000. Okay, and notice, right, as you go from left to right, they're in numerical order, they just keep going up. So right here is kind of my boundary. This is 0.7995, so just under 80%. And this is 0.8023, slightly above. Okay, now there are methods to pin it down even further, but basically we're going to go for this, for now, we're going to go with the closer one. Okay, so 0.7995 is closer to 80% than 0.823. So I'm going to look up what the Z-score is. Okay, so this is 0.84. Okay, so the Z-score associated with 80% is 0.84. Okay, I fill in what else I know. Okay, I don't know what the data point is, but I do know my mean was 75 and my standard deviation was 4.5. Okay, and now we just have to do a little bit of equation solving, right? I bring the 4.5 up, so 0.84 times 4.5 equals x minus 75. Okay, so over here I get 3.78 is equal to x minus 75. Okay, we bring the 75 over, 3.78 plus 75. Okay, so I get 78.78 equals x. Okay, so there's my cutoff point for 80%, which is close to 79%. Okay, so if you wanted to be in the top 20%, you would have to beat 78.78% in Mr. G. Harrison's class. Okay, so that's the introduction. We're going to solve more problems and go a little more in depth with this in the next lesson. But to practice what we've learned so far, here's some questions starting on page 196, or of course you've got your assignment to look at as well. Thanks for watching, and have a great rest of the day.